let's go to methods of gas collection. Gases can be collected using different methods depending on the properties of the gases. Number one, we have overwater method. This method is also called downward displacement of water. So the other name of overwater method is known as downward displacement of water. This is how it looks like. This is the diagram showing overwater method. So we are having the gas, then we are going to collect the gas overwater method. This is the water, and the name of this apparatus here is shown here. It's called beehive shelf. So in this method, we are collecting hydrogen gas. So in this diagram, we are collecting methane gas over the water method. So we see examples of the gases collected by overwater method include oxygen gas, hydrogen gas, carbon dioxide gas, methane gas, ethane gas, ethene gas, ethane gas, nitrogen gas, and also nitrogen 2 oxide gas. So next, let us see the property of the gas that enable it to be collected by overwater method is that the gas is slightly soluble in water, or we can say the gas is insoluble in water. So for that reason, the gas is collected by overwater method. The second method of gas collection is called warm water method. So let us start here. Examples of the gases collected by the warm water method include nitrogen monoxide gas and also hydrogen sulfide gas. So if we check how the warm water method look like, it just look like water method, but the water we are using here is warm. It's not cooled water. Check even in nitrogen monoxide, it is collected warm water method. So what property makes nitrogen monoxide gas and hydrogen sulfide gas to be collected by the warm water method is that we are saying the gas is insoluble in warm water. So during the exam, you can be asked, give a reason why hydrogen sulfide gas or nitrogen monoxide gas is not collected by overwater method. Because hydrogen sulfide gas or nitrogen monoxide gas is soluble in cooled water, or it is soluble in water. So the reason why we are collecting it over warm water is that they are insoluble in warm water. So let's proceed to the third method of gas collection. It's called by upward delivery tube. Upward delivery tube. So we're saying this method is also called downward displacement of air. This is how it looks like, upward delivery tube. We have the delivery tube here and it's facing up. That means this is upward delivery tube and this is the gas that containing the gas. So here we're having wet hydrogen gas. It's dried using concentrated sulfuric acid, which is a drying agent, and the dried gas is collected by upward delivery tube because this delivery tube is upward and we're going to have the dry hydrogen gas there. So in this example, we have concentrated sulfuric acid. Here we are having wet gas in, or most gas in, and this gas is dried using concentrated sulfuric acid and it's collected by upward delivery tube. So this dry hydrogen gas. Okay. Or we say it's also known as downward displacement of air. If you check the air that was initially inside this test tube, or maybe gas jar or boiling tube, this is a test tube, then that means air is displaced downward. This is air out. So if we check again this setup here, we are having most gas or wet gas in, and this gas is dried using anhydrous calcium chloride in a tube. Then that dry gas is collected by upward delivery tube, and here we have dry hydrogen gas or dry gas. Okay, let's see examples of the gases collected by upward delivery tube. They include oxygen gas, hydrogen gas, methane gas, and also ammonia gas. If you check all these gas, they are collected by upward delivery tube. So we want to see how ammonia gas is collected. If we check this diagram, we're having here ammonia gas, and this ammonia gas is collected by upward delivery tube. This delivery tube is upward. If you check again this diagram, ammonia gas is collected by upward delivery tube. So ammonia gas is an example of a gas which is collected by upward delivery tube or downward displacement of air. So let's see the property of the gas that enable it to be collected by upward lever tube. So we're saying the property of the gas that enable it to be collected by upward lever tube is that the gas is less denser than air, or the gas is lighter than the air. That's the property that makes oxygen gas, hydrogen gas, methane gas, ammonia gas to be collected by upward lever tube, like that. So the fourth method of gas collection is called downward delivery tube, and we're saying this method is also called upward displacement of air. So this is how it look like, downward delivery tube. So the delivery tube is here and it's facing downward, and this is the gas jar used to collect the gas. So let's see examples of the gases collected by downward delivery tube method include carbon dioxide, nitrogen peroxide, we're having sulfur peroxide, hydrogen sulfide, chlorine gas, and also hydrogen chloride gas. So here is the setup for the laboratory preparation of chlorine gas, and check, we have chlorine gas there as one of the example of the gases collected by downward delivery method, and it's collected by downward delivery tube. So a gas is collected by either downward delivery tube or upward delivery tube after it is dried. So this gas is dried using concentrated sulfuric acid, then it's collected by downward delivery tube. So what property makes chlorine gas to be collected by downward delivery tube, or which property of the gas makes it possible to be collected by upward delivery method is that the gas is denser than air, or the gas is heavier than air. So let's go to the fifth method of gas collection. It's the use of syringe method. And this is how gas syringe look like. We have the delivery tube and it's collected using gas syringe. So example of the gases collected by the use of syringe method include oxygen, carbon dioxide, ethane gas, nitrogen gas, and nitrogen 2 oxide gas. And this is most oxygen in, that means wet oxygen is dried using anhydrous calcium chloride. Even here, most oxygen gas in, it's dried using concentrated sulfuric acid, and after that it's collected by the use of a gas syringe. So what property of the gas that enable it to be collected by that syringe or gas syringe? We're saying the gas has almost the same density as air. They have close or similar or same density as that of air. So we're saying note, the density of air is 30 grams per liter. So we can easily know whether a gas is denser or less denser than air by calculating the molar mass or the relative formula mass of the gas. Example, so we're having the molar mass of nitrogen peroxide written NO2, nitrogen peroxide written NO2 as a chemical symbol, has 14 for nitrogen plus 16 for oxygen times 2. When we add all this or multiply, or when we put this in the calculator, we are going to go to 46. We are going to get 46. So I said hence it is denser than air. That means nitrogen peroxide is denser than air. So the molar mass of oxygen is, the molar mass of oxygen, which is written O2, is 16 times 2, which is 32. Hence it's less denser than air. It is less denser than air. Although the density of the gas is 30 grams per liter, but when you're having a relative atomic mass of or density of 28 to 32, we are saying they are just almost close to the density of the air. So next we are going to say the molar mass of carbon dioxide, written CO, equal to 12 for carbon by 16 for oxygen. When you add, we get 28. Hence it's denser than air. So therefore, for gases whose density is between 28 to 32, like oxygen, carbon dioxide, ethene, nitrogen, and also nitrogen 2 oxide, their density are very close to that of air, and they are either collected over water method. If needed dry and pure, the use of syringe can be used. That's what they are going to say. So the sixth method of gas collection is called by liquefaction method. Example of the gases collected by liquefaction method include nitrogen peroxide gas. The property of the gas that enable it to be collected by the liquefaction method is that the gas is easily liquefied. That's the reason. So here is the setup that we are going to see how liquefaction method is done. So we have the gas, and that gas is liquefied in a freezing mixture, and we have the liquid gas here. It's collected in this tube. So we are having nitrogen peroxide, which is collected by this method. Here we are having powdered lead nitrate. When heated, it forms nitrogen peroxide and oxygen gas as a gaseous product. Then the oxygen will be collected either it can be collected by overwater method, or it can be dried and collected by upward delivery tube or the use of a syringe. Then we are having here nitrogen peroxide, which is liquefied to form dinitrogen tetroxide in the tube, which is cooled in ice plus salt freezing mixture. So this is how nitrogen peroxide is collected. So number seven is the use of the freezing method. Example of the gases collected using freezing method include sulfur 6 oxide gas. Sulfur 6 oxide gas is collected by the use of freezing method, and the property of the gas that make it possible to be collected by the freezing method is that the gas is solidified when cooled. It is easily solidified when cooled. So here we have sulfur 6 oxide gas. So we are going to collect it by the freezing mixture here, and it will be solidified to form sulfur 6 oxide crystals. So this method is called the freezing method. So this is the complete setup for the preparation or laboratory preparation of sulfur 6 oxide gas. We have the reactants to react to form sulfur 6 oxide gas. That's sulfur oxide and oxygen gas. They are dried using concentrated sulfuric acid, and the reactants, that sulfur oxide and oxygen, are heated in the presence of a catalyst, that vanadium 5 oxide catalyst or platinum catalyst. Then we are going to collect that gas, sulfur 6 oxide gas, by the freezing method, where we are going to have the ice bath or the freezing mixture. Okay.